In today's video, we're going to talk about structures or structs. And if you come from some programming languages like C, probably you're already familiar with structs. And this video is probably going to be pretty much just a repetition of some facts with there's very small amount of new things. But if not, of course, this is why I'm making this video to explain this concept. So in Go, so far we've looked at various data types. We've looked at booleans and strings and integers, floating point numbers, both 32 bits, 64 bits, all these kind of data types. But all these data types, we could say that they were some sort isolated. We also looked well at arrays, slices, and maps. But what if, imagine a lot of times when we work with data in real life, we take data that is grouped together. And these grouping of data together, sometimes they're of different types. So for example, you might imagine storing information about a person. Imagine for example, a business that is storing information about its employees. And you might have that, I don't know, like they want to store their monthly salary and for example, their name, their surname, then their age. And again, we have different we have a string type data, for example, the name and surname. We have integer type data, their age, and maybe their monthly salary, their salary, which can be a floating point number or an integer. And so we have all these data. But how can we store them together just in one place? And well, here we use structures. So what a structure is just a conglomeration, we could say conglomeration of different types of data together inside a more bigger structure, as the name suggests, a structure. So to define we could say we're gonna make the distinction afterwards, but to define a named structure, so a structure that has a type, we're just gonna say type, then the name of the structure, and then the keyword struct, and then here we're going to inside the fields of the structure. So let's now take, for example, as an example, let's take, for example, book. So we're gonna say type book struct, and then here inside we're gonna place all the parameters, all the fields of the structure. So imagine storing info about a book. What kind of information would you store about it? Well, for example, the name, you would want to store the name. Then you might want to store the author of the book. Not only that, you might want to store the number of pages. This can be done by storing it inside of an integer. And well, the price, let's store it inside a float 32. And well, what else? You might want to store the we would have to import the library for dates, etc. So for now, let's not say that when it was published. But for example, let's see year of publication. This again can be an integer. And well, other fields, you could say many other things about it. You could say genre and say string. And for example, you might say available, and this is a boolean. Okay, you might have something like this. As you can see, what all of this just means that we're defining a type to be book. So throughout our program, we're going to be able to define variables of type book. And these variables of type book will be a structure of data where they have a name field, an author field, a pages field, a price field, a year of publication, genre, and available field. And when we're going to define a new book, so of this type, we have to fill in these fields. However, we can leave some fields unfilled. So for example, let's imagine that this is for a database, okay? So imagine that we wanted to store a book that maybe is anonymous, or some kind of document, for example, that for some reason we want to store, but maybe we found online for some reason, or some other field that is left blank. Well, in that case, Go as usual would just basically fill it with with a default value, which in case of a string is just the empty string, or in case of for example, a boolean is false, and so on. And so we don't have to worry about filling every single one of them. When we create a new variable, we just have to fill the ones that are actually useful. So now let's actually make an example of creating a book variable. So I'm going to say book1, and I'm going to define it to be a book. So I'm going to say book. And to define a variable of type book, which is a struct that we defined above, what we need to say is we need to first type the name of the struct, which is book, And so the first way which we're going to see is by filling in order all the fields. So for example, let's say name of the book could be Lord of the Rings, then the author Tolkien, then you might say pages. Pages is an integer, so actually now I don't remember the exact number of pages. Let's say like this. Then the price, say 20, and actually let's say for example something like that. Then the year of publication, 1954. Then the genre, you could say of fantasy, and available, you could say true. And now now we have our struct. So let's try to print out the struct to the console. As you can see, we get it printed out in this format. Now you might say we have a structure. How do we access a specific field? Well, it's pretty simple. We do that by just saying dot and then the name of the field. So imagine we just want the name of the author. And in that case, we just say the struct name dot author, and we get in this case Tolkien. But imagine that we want, for example, the name of the book. So you go here, say name, and you get Lord of the Rings. So it's really the same thing for all the other fields. But now, before we talked about, we said that we could also define structs while leaving some fields blank. So let's try to leave the available field blank. Let's see what happens. As you can see, too few values in struct literal of type book. That is because the way in which we defined this book in this way is via a struct literal, and a struct literal requires you to include all the fields, a value for all the fields, and furthermore, it requires them to be in order. So this is why in this first type of our problem we cannot leave a field blank, but we can do that in another way. So let's again define our book 1. Then what we're going to say is going to be a type book structure. And so now, in this other declaration of a struct, we are going to specifically name the fields that we're going to define. So we're not constrained by a specific order to follow anymore. So I'm going to say name, Lord of the Rings, then author, we're going to say Tolkien, then pages, we didn't remember that, so we're not going to include it. Price, we're going to say 20.55, something like that, just to include a floating point number. Then year of publication, 1954, and then genre, fantasy, and available, you could say true, okay, something like that. Let's print that out. And as you can see, it returns the structure here. But as you can see, we did not include the pages. So what happens to the pages field? Let's try to print it out, and we will see that the pages field, since it was left, the value assigned to the latter will just be 0. And so now we've seen two ways to define structures, via struct literals, or with this other way where you can specifically say which field we're going to define. And now, as we also specified earlier, when we define it in this way, we're not constrained by order. So we could define the field for pages before, and now if I try to run again, as you can see, now the pages are defined. Everything still works, and but here again we were able to define pages first, which, as you can see in the structure declaration that we did above, is actually the third field, but we defined that at first, and it's just fine because this declaration of a structure allows to do so. Now we not only can create structs, we can also create nested structs. So an example of this can be provided exactly here. That is because, well, when we define a book struct, we're talking about, well, its name and whatever, but we're also talking about its author. And, well, an author could be formalized, we could say modeled, abstractly also as a struct. And we're going to say name, and this could be a string. Then, for example, dead, this could be a Boolean value. And you can include many other fields. For example, surname, string, and then year of birth, it's going to be an integer. And so you might have many other values. And so here, for example, we could say that inside, instead of having as offer a string, we're going to have as an offer a data type of type person. And here we will slightly modify the code in the following way. We're going to say offer is going to be a person struct, and the name is going to be John Ronald. Then the surname is going to be Tolkien. Then the year of birth 1892, and then that we're going to say true. And now we're going to pass in here, instead of offer Tolkien as a string, we're going to pass in offer. Actually, let's call it offer1, just to not make it look confusing. And now if we try to run everything again, well, here we just printed out the pages field, but let's try to print out the offer. So let's see what happens. We're gonna get back our struct that represents the offer, in this case Tolkien. And if we print out the complete structure, as you can see, we get here Lord of the Rings, which is the name of the book. Then we have the offer, which is a structure, so it's a nested structure. And then we have all the other fields as before. Now with this said, we have said enough about structures. In the next video we'll still talk about structures, but in particular about anonymous structures.